Hello, welcome to the Southern Plains Climate Science Seminar. We're pleased to have you with us for our guest speaker today, Dr. Jeff Basara. I'm Mark Schaefer, I'm the director of SCIP, and on behalf of Mike Langston and Renee McPherson at the South Central Climate Adaptation Science Center, and Kate now at the USDA Climate Hub, we're pleased to have you here today. I'd like to introduce Jeff. I've known him for a number of years, going back to days with the Oklahoma Mesonet. Jeff has quite a experience here that I think you'll find quite interesting. Jeff is currently the Executive Associate Director of the Hydrology and Water Security Program at the University of Oklahoma. He is an Associate Professor with a joint appointment in Meteorology and in Civil Engineering. And he also leads the Climate Hydrology Ecosystems Weather, or CHUI, research group. He's also director of Kessler Atmospheric and Ecological Field Station, so it's amazing that he has time to join us today, but we're very pleased to have him. Jeff's research focuses on insights in the drivers of hydrometeorological and hydrological extremes in the Great Plains of the United States, particularly around land to atmospheric interactions, and a lot of work on drought and flash floods, which he'll be speaking with us today. He has also worked with urban meteorology, severe weather, instrumentation, soil moisture, a host of other things. So it should be a very lively discussion here about the impacts between weather, climate, water, and ecosystems here in the Southern Plains. His talk is New Insights into the Complex Drivers of Hydrometeorological and Hydroclimatological Extremes in the Great Plains of the United States. So with that, Jeff?
Thanks, Mark. Yes, it's a mouthful, and I hope you all are ready to go and buckle up. We got about 2 hours of fun here. Sort of kidding. I know I heard a few audible gasps there. No, we'll try to keep it to an hour, but as you all know, in the Great Plains of the United States, we are always at the interface of some type of extreme or extreme transition, and really want to kind of spend a little bit of time today just kind of discussing some of the work we've been doing, especially over the last 5 to 10 years, into some of these areas of extremes, and really some of the impacts that we're starting to see, and then how we're growing that into new research into the future. So really want to start off with just, you know, this is but I want to acknowledge, I guess that's kind of a really good lead-in into acknowledging all the various people and students and other colleagues and scientists that have really collaborated and spent a lot of time working on these projects with us over the last couple of years, especially the last half-decade. And really kind of, you know, none of this would be possible without just a number of different funding opportunities and funding sources, including NASA, the USDA specifically, the National Science Foundation, and NOAA, which have invested resources into portions of this work, and we're extremely grateful for that support over the years. As Mark mentioned, I lead the Climate Hydrology Ecosystems Weather Research Group here at the University of Oklahoma. It sort of started out at the School of Meteorology. It's part of our hydrology and water security program as well. And we integrate our research as at least, we don't really take on a project unless it has at least 2 of these circles overlapping in the Venn diagram sort of figure. And if we can get as many of them into one, that's really the nature of the work that we try to do.
Transferred it to.
There's somebody that needs to probably mute their.
Just a reminder, if you are not on mute, please mute yourself. Thank you.
Thank you. Sorry about that. So again, I think we named ourselves the CHUI Research Group. We have this great mascot. If you're interested a little bit more about what we work on, there's our sort of our website there at the bottom. we try to keep that updated as much as possible, and you can see some of the team that works on this, because we really work as a team. Now, really want to kind of tell a story about when you talk about hydrometeorology, hydroclimatology in the Great Plains, we have some usual suspects, right? You know, there are some very specific things that kind of separate the Great Plains from other regions around the U.S. and also around the world, and that includes, you know, the typical violent thunderstorms, hail, high winds, tornadoes. I think that captures the imagination of a lot of people. Of course, we know that drought, oppressive heat, and wildfires are also critical in the region. Excessive rainfall, flooding, flash flooding, also very important. This time of year, we can get severe winter storms, including blizzards and ice storms. And nothing will promote a run on Walmart like a 3-day forecast of an ice storm and the eradication of bread and milk off of the aisles. And then even once in a while, we get these intense tropical cyclones that make their way into the southern Great Plains and have an impact on our precipitation and have some other larger impacts. And so again, here's some of the visual representation of what those features look like. Obviously, they can cause damage and destruction, and there's a reason why the Great Plains is what it is in terms of understanding these extremes, is because we are constantly oscillating back and forth between them. And for example, even this is a really good case, going back, the remnants of Tropical Storm Erin. It's not often you wake up first thing in the morning and see the eye of a tropical cyclone over the central portion of Oklahoma, producing on the order of a foot or more of precipitation in some areas and having some real severe impacts. And part of that is due to our dynamic climate across the region. We have these amazing orthogonal gradients of precipitation and temperature. It's warmer to the south and cooler to the north. What's really interesting about the Great Plains, though, is the east to west gradient in precipitation. In portions of the southern portion of the Great Plains, that can go on the order of 50 inches of rainfall on average on the eastern side, down to a foot on the western side. And this is in the absence of significant topography. So we see topography out in the western portion of the U.S. that really does impact where rainfall or precipitation occurs. But the average slope across the Great Plains is on the order of 1 degree. So that's not really a significant amount of elevation change, and yet we have this pretty substantial gradient in precipitation. That also means that if we see just a shift in any given year, precipitation a little further east, a little further west, that can lead to impacts because of the expectation of the climatological average can shift. There will be a departure from that climatological average, either too much or too little. And that's sort of the overall nature of the discussion today. But I think when we really start talking about characters in terms of hydrological and hydroclimatological extremes in the region, we've all seen these images of the Dust Bowl and the overall human suffering that occurred as a result of these types of extremes. And now this was a case where we had a feature that was going on the order of a decade, although even within that there were some oscillations in terms of the intensity of the drought. And then of course the impacts of that led to the loss of soil, the loss of vegetation, and then just immense human suffering in many respects. It's really interesting when you go back. There was a study done by Warwick in 1980, really looking at some of these periods, and you'll know, if you know your history of the region of the Great Plains. For example, in the 1930s, we saw mass migration out of the Great Plains, but it wasn't the only time. Now, this is by percentage, not by total number of people, but in the 1890s, the 19-teens, and even the 1950s, there was migration out of the Great Plains as a result of significant drought and intense heat that occurred at times within the region. So when we look at, in fact, the 1930s were overall from a human standpoint, the largest mass migration of humans in the continental United States in the last 100 years was forced by one of these hydroclimatological extremes. What's interesting is you don't see the influx that occurs when there's above normal precipitation, right? And that's been part of the story of the Great Plains over the years. Now, drought itself is interesting, and so if we just look at these drought monitor images going back, over a 4-year window from 2011 to 2014. Thanks, Mark Schaefer, for originally putting this slide together. it's a great representation of every couple of months looking at the magnitude and the intensity of drought. And so through 2011, we saw the rise of really extensive and exceptional drought across the southern Great Plains, especially Texas and Oklahoma. That's when we had not just very dry conditions, but oppressive heat during that window of time. You actually see that wanes somewhat, and in April of 2012, actually most of that drought had certainly retreated. And then we see the substantial central U.S. drought of 2012 that occurred a little bit further north, but also equally intense and actually more expansive across most of the United States during that window. And then that lingers into 2013, and then we see the Great California drought begin to occur in the tail end of 2013 and into 2014. But if you look at, during this 4-year window, there's no point in which the southern portions of the southern Great Plains did not have drought. And of course, we see some changes and some strengthening and weakening with time. But during especially this 4-year window, we saw continuous or near continuous drought in portions of the region. And that's, again, going to have impacts on many different types of aspects, but especially anything that requires water resources or vegetation sustenance, especially something like agriculture. Now, from my standpoint, I'm often interested in these land-atmosphere interactions and precipitation variability. And something interesting happened while I was at my desk and reading this article. And there was a reason why I was interested in it, because it was on the southern Great Plains and drought and floods, and I was really interested in this article. Plus, if you look at the analysis they used a lot of mesonet data for particular analysis. So they were showing these 2 years, 2006, which was a drought year, 2007, which was a very, very wet year, especially in the summertime, and they were doing some comparative analyses between the two. But something I read in the initial abstract that you may have missed when I popped the slide up initially, let me bring that back up and highlight it, was actually kind of a shocking statement. And I'll kind of even read it to you, that the hydrological years of 2006 and 2007 provide a unique opportunity to examine hydrological extremes in the central U.S. And this is where it gets really interesting, because there are no other examples of two highly contrasting precipitation extremes occurring in consecutive years at the southern Great Plains in recorded history. Now, as Mark mentioned, he and I were both at the Oklahoma Mesonet for a number of years and at the Oklahoma Climatological Survey in various capacities. And so over the past 25 plus years that we've both been around, I saw that and I thought that doesn't seem like a very accurate statement, because I immediately was drawn to 1956 and 1957, the part of the peak of the 50s drought, which was eradicated quite rapidly in 1957. And I thought, maybe we should go back and look at this particular case. But actually what really this prompted, it changed everything. And this whole study this whole paper launched a whole study, a whole series of studies, and changed everything about how we look at precipitation and extremes in the Great Plains. And so what we decided to do was go back and look at what we call dipole transition. So something like 2006 to 2007, where very dry to really wet, does that occur? Had it occurred in the past? Had it occurred, I mentioned 1956, 1957, are those the only 2 years that something like this happened? So we decided to look at what we call dipole transitions, or extreme wet to extreme dry, or these large changes from sort of wet to dry types of conditions. And one of the reasons why is obviously when we get these wet periods, they can erase multi-year droughts in a matter of months. And so we're really interested in this. And I had a couple of students at the time, seniors in the School of Meteorology, that needed a project. And we put this together, we worked on it. And the end result was this nice published work in the Journal of Applied Meteorology and Climatology. But let me show you the results, because this is actually kind of interesting. We looked at 3 different areas and looked at these transitions from wet to dry on a year-to-year basis. And we had the southern Great Plains, the northern Great Plains, and then the high plains, which fundamentally is somewhat different than the northern and southern Great Plains. And what was interesting is that if you're in the most extreme types of drought conditions, you have about a 1 in 4 chance of not seeing a normal year of precipitation,
but actually seeing about the opposite, an exceptionally above normal year of precipitation. And that's actually kind of a fascinating statistic when you think about it, that through the history of this region, yes, we're going to experience drought, but in many of these cases, what we see immediately following is this rapid transition to something that is completely opposite from a hydrological standpoint, about 1 in 4 chance. So I'm not telling agricultural producers at this point to bet on something like this, but it is something that's important to kind of think about, especially if you could forecast that you're going to go into a significant pluvial event the following year. When do these happen in terms of when do we get the rainfall that breaks these types of drought conditions? Well, it's different depending on where you are in the southern Great Plains or northern Great Plains. Southern Great Plains, we see a lot of fall rains as well as some spring rains that are really critical in terms of breaking these types of drought types of conditions and initiating one of these above normal precipitation periods. The northern Great Plains is really just one month. May is a very critical month. So to go from drought to pluvial, if they get a lot of rain during the month of May, that's going to sort of lead them into a totally different regime. And that seems to be pretty consistent. What's also interesting is if you go to the high plains, I mentioned that region is fundamentally different than both the southern plains and the northern plains. Their maximum actually is really centered on the month of September. And if you know your history of flooding in the lee of the Colorado Rockies, September is a huge month for those types of conditions. So what we found was that, there are these transitions that do indeed occur. And what's also interesting is we found that they tend to break periods of drought, for example, the 1930s, the 1950s. They are very important in breaking those types of conditions. But when we also started breaking down the statistics, we began to notice that these events seem to be increasing with time, depending on how you break down the statistics. But in all cases, what we saw essentially before 1960 was about 1 in every 18 years. We'd see one of these transitions. Since then, it's about 1 every 9 years. And then even within the last decade to decade and a half, it's actually accelerated to about once every 3 years. So we are seeing some increase in the variability of these types of events as we move forward in time. Now, the impact of this is actually kind of important. So here's an example that was mentioned, the Kessler Field Station that I also am the director of. And this is our lake at the Kessler Field Station just southwest of Norman. And here's what it looks like in October 2014 after several years of drought, and it had been a rather dry year. 2014 was a drought year across portions of Oklahoma. Our lake was rather low. In fact, it was getting very low. I don't know if the pictures do it justice. The vegetation, yes, it is at the end of the growing season. The vegetation is generally dormant, but you can kind of see that it's not healthy in this picture on top. And then after 2 feet of rain during the month of May, that's right, 2 feet of rain during the month of May in 2015, this is what it looks like. And you can actually see that if an ecosystem could express joy, this is, I think, what it would look like. Notice how green and lush the vegetation is in this overall recovery. Look at the height of the water. Obviously, the lake has gone from about 2 acres to 8 acres. In a relatively short amount of time, but also look at the water quality, right? So there's increased runoff, and so during these events, we can have a degradation of water quality and above ground storage. And so there are all different types of impacts that can and do occur with these types of rapid transitions from one regime to another. What's interesting about this is just, if you plot up, I like looking at lots of time series of precipitation. Here's a number of time series of precipitation accumulation for Oklahoma City, and this actually goes from 1948 through 2015. And what's interesting is each one of these lines represents a different year, starting in January and ending in December 31st. This orange line in the middle represents what would be normal or the mean of all of these curves. And what's interesting is you kind of see an envelope on one side or another. So below that would be overall drought. Above that would be, pluvial types of conditions. And if I draw a line in here, which is about 50 inches, actually a little over 50 inches, you see some very interesting trends. And I mentioned some of these extremes. If you go back into the history of Oklahoma City, the first time it ever recorded over 50 inches of rainfall, which is not on this image, but over 50 inches of rainfall in a year was 1908. Now, if you're a Chicago Cubs sports fan, you know that's a very important year, because prior to 2016, that was the last time they won the World Series. So that was a long time ago that we hit above 50 inches of rainfall at Oklahoma City. And it took almost 100 years until it happened again in 2007. And then what's amazing is it's 2007, 2013, 2015. And if you really look at these years, 2007, 2013, 2015, we see something fundamentally different about those years compared to the long-term trends that we would observe normally. This what I would consider almost like the normal envelope of precipitation at Oklahoma City. There's just inherently something different. A lot of really heavy rainfall events, obviously, that help the precipitation get to over 50 inches. By the way, Oklahoma City during 2019, 45.34 inches of precipitation, which doesn't quite get above that 50-inch range, but it does put it at the top of this envelope. So just in the last decade, we've seen, last 12 years, we've seen a number of incredibly excessive rainfall years in Oklahoma City. At the same time that we've seen a number of these excessive drought years in the region. So this kind of, again, highlights the fact that we are seeing different types of extremes on both sides of this. It's not just one side, it's on both sides, both drought and pluvial types of years and conditions. And so, part of this drought to pluvial transition is, okay, we can understand droughts, but we also need to understand the other side of it, which is the pluvial side. And the impacts of this, again, I show this because I think this is pretty graphic. This is 2015, again, and this is Northeast Oklahoma, Grand Lake, Oklahoma, Little Blue State Park. This is not where you're allowed to go camping. In fact, it was cordoned off, and I was nearly arrested taking this video. And the only reason I got out of being arrested for taking this video is because I told them it's for educational purposes. And so I show this as much as possible, but this is not exactly what Little Blue State Park is supposed to look like on a normal given day. And the excessive precipitation during 2015 has impacts. And so we did see flooding across the state as a result of all that precipitation. Now, what we decided to do is, okay, so we need to understand these pluvial years. When we get these really wet years, what's going on? I can't go into all of the details of how we did this study, but we did a pair of analyses, and this was done by Paul Flanagan, who recently finished his PhD in the School of Meteorology. He's now at the High Plains Climate Center in Lincoln, Nebraska, as a postdoctoral scientist. But he did these, as part of his dissertation work, we looked at these types of conditions. Now, we know that El Nino and La Nina play an important role in drivers of extreme precipitation in the region. So what we did was we went back and we looked at a number of different data sets to try to isolate when we would see excessive rainfall in both the southern Great Plains and northern Great Plains, and then try to isolate do they have similar characteristics or similar types of environments? And there was one feature that showed up in over half the cases. It doesn't represent every case, but it represents over half the cases in which we see that there's very warm tropical sea surface temperatures that occur in the equatorial regions. But unlike a true El Nino, the maximum is actually shifted further out into the central Pacific, south of Hawaii. So that's where we typically see the stronger or the warmer sea surface temperatures. What's interesting is that what that does is it actually creates a ridge just to the north, a mid-tropospheric ridge, and we often see with it a strengthened dilution low. And what that does is it creates a stronger jet, a stronger zonal jet across most of the Pacific during these periods of excessive precipitation. At the tail end of that jet, we often see a number of sort of a semi-permanent upper level trough and a number of cyclones that will develop across the southwest portion of the U.S. When that happens, that actually induces a lot of southerly flow and moisture transport from the Gulf of Mexico, but also from the Eastern Pacific, and even some of these atmospheric rivers that we hear about sometimes making their way into the Great Plains. And with all of these ingredients in place, we end up with more precipitation over the region. What's amazing is the consistency of these types of analyses. What's also amazing is we did not include either 2015 or 2019 in this analysis. 2015 was a similar case. What about 2019? Let's take a look at 2015. This is the precipitation from NOAA for the water year of 2015. And actually, if you go back and look, pretty excessive precipitation, over 20 inches above normal for the water year across large areas, over 10 to 20 inches across huge areas of the southern Great Plains. And we know that this was a similar type of pattern that was, but it was also a large El Nino year, just in general, across, it was a very strong El Nino. So there's some, potential confounders that it was just a strong El Nino type condition. Well, 19 wasn't. And we saw something that looks like this. Actually, if you look at the expansive precipitation, and it's actually a much greater year in terms of overall excessive precipitation across the U.S. In fact, it was across a couple of rolling windows, it was the wettest year on record across the United States, depending on which 12-month interval you use. In fact, you can use multiple 12-month intervals, and you still end up with the same conclusion. We see all this excessive precipitation. Unfortunately, or fortunately, Oklahoma City didn't quite hit that 50-inch mark, but it was pretty close. And we see that there was a lot of, especially Kansas and up into the Midwest, excessive precipitation during 2019. What's interesting about it is it led to basically the eradication of drought, which is good across most of the U.S. But on the same time, we had a significantly above normal precipitation. We did see a lot of flooding, especially the Missouri River flooded pretty substantially for a couple of different reasons across the upper Midwest. We saw quite a bit of flash flooding and river flooding across other portions of the U.S. as well. What's interesting about this is when we go and we look, there's the above normal sea surface temperatures in the tropical Pacific, sort of south of Hawaii. And what we saw persistently across that region was a strong zonal jet with an upper level trough in the southwest portion of the U.S. And this is going into mid-May of last year. And in May of last year, just here in Oklahoma City, we had over 12 inches of rain. And so this was the type of pattern that we saw. So this was a very consistent pattern. So when we see something like this now, we have greater confidence that we're going to have excessive precipitation over certain windows of time, and maybe more seasonal to even interannual types of precipitation, excessive precipitation. And of course, the impacts of that are also pretty profound. So we looked at the Dust Bowl images of and drought. Well, this is last year across large portions of the central portion of the United States, the Great Plains extending into the Midwest, and the crop yields were low, excessively low. We don't know the exact statistics yet because they're still being processed, but we do know that it will go down as a low year on record, on par with some of the more significant drought years that we've had across the same region, mainly because of too much water. So we can have too much water in these regions. Now, there was another study by, I've kind of shown that we see that the acceleration of the hydrologic cycle there was another study actually published in 2016 by Weaver et al. It also has been pointing that out, that the variability of precipitation in the southern Great Plains has been increasing with time. And so I had an ecologist, there's an ecologist colleague of mine, Zhangming Zhao, asked a very important question one day, just in a meeting with Paul and I, and asked, in many grassland ecosystems in the world, the maximum in temperature and the maximum precipitation happen about the same time of year. But in the Great Plains, that's not the case. So has anybody looked to see if it's changing? And that was a very interesting question. So Paul decided that he would look at that. And what he found was something interesting. So this is kind of the conceptual diagram. The peak of temperature happens at the end of July and early August, the peak of precipitation May into early June. And there's about a 60-day window between those two peaks. So this is kind of the conceptual idea of what we were looking at. And so we wanted to look and see if there was anything going on between these two peaks, not necessarily the magnitude, but more the timing. And what one question was, did we see a shift to maybe earlier in the year between these two peaks? And when we looked consistently at it, the answer was no. We did not see a consistent shift to earlier in the year between these two peaks. We then asked, did we see a consistent shift to later in the year between these two peaks? And the answer to that was also no. We didn't see a consistent shift to later in the year. Well, what about, so what did we find? What we found was that the overall variability is increasing between those two. So sometimes we get it later in the year, sometimes we get it earlier in the year, sometimes the peaks are closer together, sometimes the peaks are getting further apart. And when we looked at the temporal variability of these two features, the overall variability is increasing. So we see some of the variability in magnitudes, but we're seeing also variability in timing. And from an agricultural standpoint, this is actually very critical because it's not just the amount of precipitation, but timing of precipitation that matters. And so again, from just a total water resources standpoint, this is important. But the overall variability is just changing, is increasing across the region. Now, what might be causing some of that variability? Well, some of it might be global conditions, like what we just looked at in terms of drivers of excessive precipitation, literally starting out in the middle of the Central Pacific. But some of it might be closer to home. And there have been a number of studies that have shown that land-atmosphere interactions play a very important role in driving the hydroclimate of the region and precipitation recycling potentially, but also some of these feedbacks that may drive one extreme or another. And so we started looking at also at sort of the land-atmosphere interactions portion of this. And one of those studies, we actually looked at sort of the southern Great Plains and tried to understand, consistency, and when we have coupling, when does it really happen? When we see the strong coupling as defined in a couple of different ways. What we found was that first of all, this is an area that has pretty substantial coupling regardless. So you're going to see coupling even in years where you don't have above normal or below normal precipitation. Tends to be weaker, actually. But what is interesting is if you look at excessive precipitation on the right or a lack of precipitation on the left, the coupling during the peak summer months on the dry side seems to be, one of the conclusions from this study was that it seemed to be stronger than on the wet side. And that's an important point. So drought might be more sensitive to some of the more local effects, whereas, the excessive precipitation might be local, but it also might have significant drivers that are more global, like I just described a bit earlier. We had another, more recently, we had another study by one of our students, and she was looking at this from a different perspective, but kind of came to the same conclusion. There's a way of looking at coupling that involves a whole lower portion of the atmosphere and the drivers of precipitation. But what she found, basically on this plot, these are all the different years from basically 2000 to 2015. And the further up and to the right you go on this plot, that is dry coupling. And the further to the low and left on this plot is wet coupling. And you kind of get, and what is interesting is all the drought years sort of end up in this upper right portion. And the one that most sticks out is 2011, which was especially over Oklahoma. This was an exceptionally dry, hot, coupling type of environment. It was a very hostile air mass, and once it kind of got going, it really suppressed convection and suppressed precipitation. But all the drought years sort of show up, the significant drought years show up in this upper right, showing that there really is a strong relationship between sort of local factors like soil moisture and the atmosphere above, and then the lack of precipitation. What's also interesting is that in the lower left, there we see 2007, which was a very wet year, also in the southern Great Plains. But 2015 is actually almost centered right in the middle. And what we know about 2015, it was largely forced by something much further away than the local environment. And so when we do look at this, we do see that the drought side seems to have more of an impact by the local conditions than the non-drought side, so some of these extreme years. So we could get coupling that will then produce, precipitation recycling. 2007 appears to be one of those years. But then we can just have the overall large-scale atmospheric dynamics are just kind of imposing their will from something that's much larger and much further away, causing the excessive precipitation. And there may be some coupling, but it's not necessarily all driven by the local conditions. So kind of an important study along those lines, that we see these feedbacks might be stronger on the drought side than on the above normal precipitation side or on the pluvial side. Now, again, this is all going back and forth. This is what we call sometimes weather whiplash, this sort of transition between these different regimes. And again, here you have on here 6 different extreme years within basically a 15-year window. That's sort of what it's like to live in the southern Great Plains and just the Great Plains in general. So what that has also led, though, is when we start looking at coupling and we start looking at drought, some droughts seem to form faster than others, and they occur with rapid intensification. And kind of, there's been a number of articles recently in the science that have kind of highlighted that the concept of what's called a flash drought. So this is actually going back to 2012. This is a site in north central Oklahoma near Marina. We had a camera set up, literally watching the grass grow as part of a project that we have with the grazing cap and others, to visually observe the vegetation. And this is what it looks like on July 1st of 2012. And then this is what it looks like 31 days later. And we saw basically a complete desiccation of the land surface during this particular point in time, a rapid intensification of drought conditions. At the tail end of this, we saw really high temperatures, surface temperatures that basically were 100 plus for days on end, 110 plus in some cases. So this was a kind of a brutal end of the 2012 summer, but we see this rapid desiccation of the land surface, and this is consistent with what is now known as flash drought. Now, there was a great article by Jason Otkin kind of outlining what should be defined as a flash drought, meaning the rapid intensification of drought and drought stress due to enhanced evaporative stress from the land surface. And so one of our students recently published an article in 2019 in the Journal of Hydrometeorology looking at a number. He had 4 different criteria and sort of the outline of the concept of in the Otkin et al. Paper to actually develop a whole methodology to identify flash droughts. And then we applied this to different data sets, and this is the North American Regional Reanalysis, and compared it to some observations as well. But this is what it looks like. What are the areas that are most likely to have flash drought conditions? Keep hitting the wrong button. The Great Plains are a temporal hotspot. We see a number of these. Come on, stop it. We see a number of these events happening in the climate. Also in the Midwest and other agricultural areas are prone to these types of features, but especially in the Great Plains and the grassland regions of the Great Plains, and then also into the Corn Belt region. So this is a really important study looking at not all drought is the same. Some drought develops over long periods of time, and some can rapidly develop. And where do we see some of these extreme cases of rapid development of drought? So right here again in the Great Plains. We've taken a look at this and applied it to some interesting cases, the methodology that Jordan developed to identify flash droughts. And you can really see this graphically in 2012. There was a remnant portion of drought left over in 2011 across the southwest portion of the U.S., but most of the central portion of the U.S. was relatively drought-free in early April. But what we see is that beginning in Kansas and then spreading out from there sort of radially over the course of a couple of months, these are all places that experienced rapid development of drought via Jordan's methodology. And then essentially by the end of the growing season, the end of the summer, most of the central portion of the U.S. had not just experienced drought, but this rapid transition to drought over short windows of time. And it literally looks like it spreads like a grass fire, basically across the central portion of the U.S. And we see this in some of these cases, the propagation. What turns out is that there are some land atmosphere feedbacks and sort of that play an important role in sort of the downstream transition of these flash drought cases across these regions. And then Jordan took it another step further in a new article that just appeared. He wanted to look at some of the regional characteristics across the U.S. Now there is a peak across the central part of the U.S., but he wanted to look at some of the other characteristics, and they don't always occur at the same time of year, depending on where you're at. In the plains, the starting month tends to be June, which makes a lot of sense around here. In other locations like the Great Lakes, it's later in the year. In the western portion of the U.S., it's actually a little bit earlier in the year. And there are some of these interesting regional characteristics that do sort of pop out. One of the other interesting characteristics that he found was that this is when, the conditions with which flash drought occurs. And what's amazing about, if you pick out the southern Great Plains or northern Great Plains, a lot of these have you have to kind of get a kickstart to drought, or drought is already on their way before it starts getting really bad. But in the central portion of the U.S., you have about 45% of the cases, 44% of the cases in the southern Great Plains, and 44% of the cases in the northern Great Plains have actually occurred. We had flash drought cases that occurred when the conditions were initially pretty good, or even above good, like 2012, where there had been an ample spring rain. It had been warm, but there had been ample spring rain. The evaporative stress was not that high, and then it rapidly transitioned to drought. So these rapid drought development cases can actually occur during conditions where basically the floor drops out, where you feel like you're going along pretty well, and then all of a sudden we start getting a rapid drying period, and then before you know it, within 4 to 6 weeks, rapid drought has set in, and it's intensifying rapidly. This actually kind of occurred even this last year in 2019. Didn't quite get the flash drought conditions, but we saw about 45 days of lack of rainfall and started to tend towards drought, even in a year of well above normal precipitation. So we do tend to see these types of conditions, and that's one of the interesting facts is that about flash drought in the region is that it can actually occur when you think that you might not expect drought to occur. In a short window of time, it can rapidly develop. So from just this is kind of wrapping it up, part one, looking to the future. I've kind of shown a number of these different types of events, and we've kind of transitioned sort of as the hydrologic extremes transition. So we started in drought, we ended up to above normal precipitation, we're back to drought, we're going back and forth. But we need to continue this type of research and look at some of these processes. And, we haven't really discussed it. We're looking at the Great Plain, but are there global differences, for example, in flash drought? But also in these transitions, we're starting to really look at the transitions. Dr. Eleanor Martin and I have a student that's working on this, not just in the U.S., but globally. Are we seeing these types of features? Where do we see them more versus less? And what, are there different trends of some of these features in different locations? Some of these flash drought cases are interesting, like 2012. Others, like 1988, are explosive and explode over large areas over relatively short windows of time. What are the characteristics that drive those types of features? When we look at the subseasonal to seasonal, what we call the S2S, what are the key drivers of some of these features? When do they phase that really promote these extreme events on either side, on the wet and the dry? I think there's still a lot of uncertainty and some major questions associated with that we still need to address. And then we also obviously need to continue on the impact side of this into ecosystems, agriculture, and I'm going to show a couple of more examples, I think, of why this is important for current and into the future work. But when we start thinking about the ecosystem and the human system, all of these extremes and any acceleration or whiplash that's occurring within the hydrologic cycle does have impacts. One case, let's take a look at this one on wildfires. So not all drought is the same, and not all drought is flash drought either, but this was actually a flash drought that occurred across the northern Great Plains during the summer of 2017, and at the end of 2017, there was substantial drought that had occurred in that region. But if you notice, the southern Great Plains were, for the most part, drought-free across the southern portion of the domain. What's interesting is this is September 5th, and if I just go forward 6 months, The drought is now basically gone across the northern Great Plains, but has become incredibly entrenched. Now, this is occurring during the cold season versus during the warm season, when we would normally expect flash drought to happen. So this is driven by different processes. But notice this, you know, if you're out there at Guyman or Goodwell in the central portion of the Oklahoma Panhandle, went from drought-free to exceptional drought in a matter of months. And what are the processes that caused that? Well, it's interesting. Let's take a look at Goodwell, the Goodwell Mesonet site. And the black line is the climatological accumulation at that site, measured over basically a 20-year window. And then the purple line is what actually happened in 2017. And what we see is that it starts off basically, anytime it's above this line, it's above normal precipitation. Anytime it's below this line, it's below normal precipitation in terms of the overall accumulation. And there was some precipitation early in the spring, and then whenever you see a flat line like this, it means it didn't rain for an extended period of time, or just a lack of precipitation. But at any point in time during 2017, Goodwell was never below normal in terms of precipitation. In fact, the accumulation during the growing season was pretty substantial, pretty dramatic. And Goodwell ended up finishing about 5 inches above normal for the year, which when you're dealing with only about 16, 17 inches, that's a pretty substantial amount of precipitation. But beginning basically about October 1st, drought begins. And we see this long period of no precipitation. And what's interesting is that it continues on into 2018. In fact, we don't really see that precipitation really get going until basically late May into early June. So there's a 6-month window here of basically 2 inches of rain. And then again, rapid accumulation of precipitation during the summer months. And actually at the end of 2018, the Goodwell area had even more precipitation than during 2017. And actually, if you fast forward this to 2019, 2019 was above normal again the whole year. So 3 straight years of above normal precipitation out at the region with an exceptional drought in the middle. This is what weather whiplash and hydroclimatological whiplash looks like in this region. And we need to understand these processes because they have impacts. And in this case, some of the impacts were because there was so much precipitation during the growing season, it led up to the excessive green up of the vegetation. And then during this long periods of dry down, in fact, if you go back to both of these years, we have long dry down periods after all that vegetation has greened up, which then dries out the vegetation. And when the right conditions come along for wildfires, we have these exceptionally large wildfires that exist. In fact, in 2018, April 2018, these are some major wildfires that were occurring in northwest Oklahoma and in and around Woodward, and had burned exceptionally large areas. And so there is a relationship between the ecosystem here and what's happening with some of these hydrological and hydroclimatological extremes, and there's certainly some substantial impacts that we need to continue to look at. Another thing that we're looking at, actually, we're looking half a world away, because I think that this actually plays an important role in things that are going on here. But we're looking at a flash drought case that happened in Russia in 2010, because we've now, using Jordan's methodology, expanded his analysis to global regions. And a very significant flash drought occurred on the south of Moscow in 2010. What's interesting about that is 2010 was also what's called the Great Russian Heat Wave. But the flash drought actually happened about 6 weeks earlier than the actual heat wave event itself. And there's been a number of studies that have kind of looked at this and some of the reasoning behind, but they noted that the drought conditions are important, and it really was a flash drought that developed across that whole huge region. And it led to a massive desiccation of the vegetation by the middle of the summer. And then eventually the heat wave in Moscow, what's been shown in a number of recent studies is that the heat actually, there was a heat transport from over the flash drought region into the Moscow area. So what initially started out as a flash drought across the portions of southern Russia ended up becoming a heat wave event in another location. And there were a number of compounding factors. So in this case, we're looking at these cascading events that may have been started by a hydroclimatological feature in phase with other processes that led to a heat wave event. And what's amazing is that there were wildfires, air pollution, and above mean increased human mortality. In fact, over the mean, about 11,000 extra fatalities during this window of time. And really it begins with a hydrometeorological feature that starts about 6 to 8 weeks earlier. So could something like this happen in the US? In fact, we think that it might have already happened when we go back to 1988. And so we're continuing some of this work looking at these linkages and what we call cascading impacts. So sort of to wrap this all up, thank you all for sort of listening in on this, but here's sort of the takeaway message. And beginning with just some research that was supported from a variety of reasons, what we've really begun to understand about the Great Plains, yes, we know we have dynamic weather and dynamic climate, and it's always been variable. However, when we look at some of these extremes, that variability appears to be increasing with time. Now, we haven't even looked into the future. We're just looking at the climatological records and looking at it from a couple of different perspectives. And every time we turn sort of a new stone over, we're getting the same answer in one sense of the overall issue is that the precipitation variability is increasing, and we're seeing just this rapid transition back and forth between these extremes, and that appears to be accelerating with time. Not just on an annual basis, but even on a sub-annual and seasonal to sub-seasonal basis. So we're going to, at this point, we will likely see the increased frequency of these oscillations between drought and pluvial periods. But also, and that impacts features like the asynchronicity between temperature and precipitation in the region, which has impacts on agriculture. Some of these are driven by local processes, some of these are driven by global processes. So teasing out the factors is actually is very tricky, especially when we're trying to understand the predictability of these types of features into the future. And obviously all of this impacts socioeconomic sectors, especially agriculture, but it's not limited there. It's also overall water resources, and also just, human health, especially in cases where we have too much heat that can lead to really adverse conditions as well, or the lack of it. And by the way, there's some new research that's being done out of the University of Nebraska. And just looking at the overall health impacts of drought, and that there's more to it than just the heat portion of it. And we know that, but all of these features have many different types of impacts across many different socioeconomic sectors. When we think about things even like blue-green algae in some of our lakes in the summertime, they're likely being impacted by some of these types of features. And overall, I think it's just simple to say that there's still much, much work to be done, and we're looking forward to continuing this on into the future. So I will leave it open for questions at this time.